So let's continue looking at the location of images in plane mirror. So here we are to look at location of images in plane mirror. How can we locate the position of images in a plane mirror? That is the idea of this session now. So what would be the step we should follow in the locating images in plane mirror? If I can draw a simple sketch of our idea there, I can have my object here, something of the kind, and then if I have an object there, I can draw something like that. I can draw something like that. If I extend this here, and then as well I extend this here, I put here point, and then I put here point. I can now call this one here P1 and P2. I could call this one P1, I call this one P2, and then I call this one P3 and P4. This will be my object. And this one here will be where the two rays meet, is what we're calling my image. So, what is the procedure number one? Number one is place a plane mirror. Place a plane mirror on a white sheet of paper and press on a white sheet of paper and draw a line to represent its position A, B. So if I have here A, B, I place a sheet of paper on a table and then I draw a line. That line will be representing the trace of the mirror. And then next I can say place an object or in front of the reflecting surface, reflecting face. Let's call it reflecting face of the plane mirror. Okay? And then while observing from side A of the mirror, comma, fix pins P1 and P2 such that they appear to be in a straight line with the image I. And then finally you can repeat the procedure on side B for pins P3, P3 and P4. And then lastly, you can remove the mirror and extend the lines P1, P2 and P3, P4 to meet at point I, and then this, the point of intersection, is the position of the image. That is what you can basically talk about, or what you can easily describe if they ask you how can you use a plane mirror to locate the position of an image. So we are saying that in step number 1, get your plain sheet of paper. After getting a plain sheet of paper, place the mirror standing in vertically and draw a line to represent its outline. When you're placing the mirror standing, so that one side you can see and then the other side is silvered. So if you place the mirror standing, you can put an object in front of the what? You put an object in front of the mirror A, B. So after placing an object here, what happens is the image will be formed somewhere behind here at point I. So now what you're supposed to do is move one side of the mirror. An example is the other side. The mirror will be standing, the mirror will be facing you, an object will be in front of it. So if you come this other side here, what you do, place 2 pins, place them in such a way that these 2 pins appear to be in line with the image of this object at this point here. So put this pin and this pin so that the image of this that you're seeing, of course when you're seeing from this other side, you'll be seeing the image of this object here at this point. So when you're putting these 2 pins here, make sure that the arrangement is in such a way that all the 3 are in a straight line. And then having done that, you come also on the next side of the mirror. That's why I'm saying that place the plane mirror on a white sheet of paper and draw a line to represent its position A, B. Place an object in front, it's supposed to be an object. Place an object in front of the reflecting face of the plane mirror. After placing an object here, next is while observing from side A, as we are seeing from this other side of the mirror, fix pins P1 and P2. We put these pins P1 and P2 such that they appear to be in straight line with the image I. Is that okay? Now after doing that, you come this other side of B. We're saying repeat the procedure on side B for pins P3 and P4. So that means that you come and now make observation from this other side. I'll come and make observation from here. Put my eyes here at this point here. And then make sure that also the pins I'm putting, they appear to be in straight line with also I. So having done all that, next is remove the mirror and extend the lines P1, P2. After removing the mirror, this line here which was stopping here, extend it, okay? And also extend this other line so that they intersect. Clear? Where the 2 intersect is the position of our image. By doing so, you would have located the position of the image in a plane mirror. Is that okay? Let me hope we are still together. So having looked at that, let's rush and look at one simple numerical problem here. Let's look at one simple numerical problem. What is that example telling us? Example. Example, we're saying a man whose height is 2 meters and the eye level at 1.84 meters above the ground wishes to observe his image fully in a plane mirror. Calculate the length of the mirror that should be provided. Is that okay? So we are having an example here that there is a man of height 2 meters. He is 2 meters tall, and the level of his eye, measured from the ground, his eye level is at 1.84 meters above the ground. And this very guy here wishes to go in a mirror, stands in a mirror, and he wants to see the whole of himself. That is to say, from the head up to the toe down. He wants to see himself in the mirror. Now, the question is, what should be the length of the mirror that should be provided to that guy with all those properties of total height of 2 meters and eyesight 1.84, such that he sees himself fully in the mirror? So that is the question we are supposed to analyze now. So maybe we would first begin by looking at some simple sketch of our idea. Here we are saying that we have this guy here. Don't mind of my sketch, but just something to help me in interpretation. If this is the ground level, the eyesight could be there. Okay? And now this is a guy they're telling us is 2 meters tall, but the level of his eye measured from the ground is 1.84 meters. 1.84 meters. So what should be now the height, the remaining height above? Okay? That is now 0.16. 0.1. Is it true? Is it true? To get this height here, you say the total height of 2 meters, okay? The total height of 2 meters, subtract away the height from the ground up to his eye to get this up to that. Is that okay? So now if I have that, let's look at the reflection how does the ray of light actually reach this guy here? If I have that, if I have this, I can have this, and then I can have this. The light rays will move, come here. The light rays will come and then reflected in his eyes here. And this is the normal. So this is I, this is I. Is that okay? That is for him to be in position of seeing his forehead. That means that to see his head. That means that the light rays move from there, comes to the mirror, and then reflected in his eyes. Then there, he will be in position of seeing his head. And then from the leg, it means for him to see, the light rays will come here, and then reflected you will use a ruler to make a clear drawing. This is I, this is I. Is that okay? And now this could be the length X of the mirror that we are interested in. That if the arrangement is now in that format there, this guy here will be in position of observing himself fully in the mirror. Because now from here, light rays from the head will come to the last part of the mirror and then reflected in his eyes. And now from the foot, come here, reflected in his. That means that at this point I see the leg up to this point, but using this length of the mirror. So now, how do we get the length of the mirror? So if this is point O, E, and maybe C. Okay? So I can call this one N, I can call this one B. Is that okay? So from the diagram, I'm interested in getting X. From the diagram, okay, what is very true is that after looking at this angle being equal to this, that means that this line here, if we extended this line here, if I can draw a line like this length here is equal to this length. If this angle is the same as this angle, and this height is common to all of them, this length is equal to this length. Is that okay? So that means that I can say EN is equal to ON, okay? This length is the same as this length, and this is a half of OE. A half of OE. And that is a half of, what is OE? A half of 1.84. And that is equivalent, you can pick your calculator there. That will give us 0.92 meters. If you're pressing very well, that is equivalent to 0.92. Because we are saying that this, from laws of reflection, this angle is equal to this angle. And if you join this triangle here, you're looking at this, you realize that they're all sharing this height here. So if this angle is the same, that means this also is the same. That is say ON be equal to NE. And if they are the same, that means that they will be half of the total length here. And that is half of 1.84, that is giving us 0.92. What else is very true? Also, what is very true? If I extend this normal here up to this point here, okay? If I call this one maybe say B, it is also very true that EB, because this angle is the same as this, and this height is this, the height is common for them, that means this is also equal to that. So, if that is the case, I'll say EB is equal to BC, which is now a half of EC. And that will be a half of, what is EC there? EC is 0.16. So I beg you pick your calculator there and say what is a half of 0.16 or 0.16 divide by 2. If you've pressed very well, then you're going to come out with 0.08 meters. Is that okay? So that is now this distance, that distance. But what do you think is very true? We said we want the length of the mirror X. And I'm now saying that the length of this mirror X here is equivalent to EB plus EN. The length of our mirror here, BEB, X here, is the same as this distance and this. That will be representing this length here. That is B presenting this length here. And that is the X we are talking about. If you look at that, and then look at this here. So if I add that plus that will be our X. So therefore, I'm very proud to tell you that X is equaling to EB. My EB, we already said, is 0.08 meters plus the the EN which is 0.92 meters, and that is giving us a distance of 1.00 meters, or just 1 meter. Therefore, you can conclude and say, therefore, the length of the mirror, that should be provided is 1.0 meters. Is that okay? So that is if at all they have asked you to answer such a kind of problem. So that means that the length of the mirror that should be provided should be a half the height of the man, in order for him to be in position of observing his height of 2 meters fully in the mirror, having an eyesight of 1.84. So that is how the working is supposed to be done.